Math 3, Mod 1, Practice Problems 1.1 through 1.3, question number 5. A great place to refer back to this would be, again, Toolkit Notes, where we did evaluating functions. And function notation. So we're going to use the functions below, f of x, g of x, and h of x to find the following. F of x is 5x, and I'm going to use that and substitute in 2a plus 3b as my input. So I'm going to plug that right in for x. So 5 times 2a plus 3b. Distribute my 5. And I would get 10a plus 15b. Substituting 2a in for my g function, again in for the input of x, so 2a squared plus 2 times 2a minus 1. 2a squared literally represents 2a times itself, so 2a times 2a, 2 times 2 is 4. A times a would be a squared. 2 times 2a would give me 4a, and then I would still have my minus 1. No like terms here with my a squared, a, and minus 1, so I would be done with g. And then this h of a to the 8th, so substitute that in. I have the square root of a to the 8th. I am really looking for this one, for how many groups of 2 I can get out of 8. Because a square root undoes something that's been squared, which is 2. So 2 goes into 8 4 times, so this would now be a to the 4th power. These next 3 are compositions of functions. So this one is g of x is my input into my f of x function. So I'm going to do 5 with an input of x squared plus 2x minus 1, and then again I just distribute my 5 in this case. So 5 times x squared is 5x squared, 5 times 2x would be 10x, and 5 times negative 1 is a minus 5. G of f of x, so this time f of x is my input, 5x is going in everywhere I have an x in my g function. So 5x squared plus 2 times 5x minus 1. This time 5x squared is literally 5x times 5x. 5 times 5 is 25. X squared. 2 times 5x would be 10x. And I still have my minus 1. The last composition of function is I am substituting in h of x in as my input of f of x, so 5 times the square root of x. 5 is outside of the square root, x is inside, has to remain like that, so it would be 5 square root of x. I'm also asked, what's the inverse of f of x? Well, remember, f of x is function notation, but f of x really just means y equals 5x. So I can, again, switch my x and my y, and then solve for y. So undoing this multiplication by dividing by 5, and my inverse is x divided by 5, so I can use inverse notation and write it as x divided by 5, or x divided by 5 is also equivalent to 1/5 x. The inverse of my h of x function, well, h of x also is a placeholder for y, so I could rewrite that as y equals the square root of x. When I swap my x and my y to undo the fact that the y is squared, in a square root, I would square both sides. These undo, and I would get that inverse notation. The inverse of h is equal to x squared. Kind of continuing on to talk about inverses and looking at problem 6 as well. Sketch the graph of a function that is invertible and sketch its inverse. You could choose a variety of functions. I chose a linear function. You must choose something different than this specific linear function, but yours could be a linear function. I decided to give mine a y-intercept of 1 and a slope of 2, so up 2 over 1, or down 2, back 1. And this would be my original linear function. I created a table value for this at -2. I had a y value of -3. At -1, a y value of -1, 0, 1, 1, 3, 2, 5. So then to find my inverse, again, I'm going to apply the same concept as we've seen several times already in this review, as I'm going to switch my x and my y values. So -3, -2, -1, -1, 1, 0, 3, 1, and 5, 2. Plotting those points. And I get the inverse graph.